Hello and good morning to everyone. So today I will be presenting on EBTD4103 New Design Development. So this is me, Shanu Babujarat. So you can call me Shanu, and this is my matrix number as presented on the slide. So without further ado, we will continue with the presentation. All right. So what are our topics today? So there is 4 topics today: introduction of the selected organization, analysis for the developed product, then we're gonna move on to recommendation, and finally we'll come to the conclusion. All right, so introduction of the selected organization. So I selected BMW Aerospace Sendirian Berhad. So why did I choose it? All right. I choose BMW Aerospace because it is my workplace, so I can benefit from the ease of information transfer, and I can get my information for the slide for my assignment easily. Alright, so why did I choose it? So BMW Aerospace is an aircraft part manufacturer that is inducted into the BMW Group family in 2015. So the developed product is a fan case kit based on the design requirement for manufacturing. Right. In 2015, they were inducted into BMW Group after signing the agreement with Rolls-Royce, which is 25 plus 5 years agreement to produce the fan case kit. Right. UMW is the first Malaysian company with the Tier 1 supplier status with Rolls-Royce. So Tier 1 companies is a big deal because they are the most important and viable in the supply chain, as they are directly supplying to the aerospace sector. So it is one of the drivers. So BMW Aerospace is one of the drivers that is responsible for ensuring the effectiveness and the efficiency of the manufacturing operation. All right, so this is what I call the pyramid structures of BMW, because it looks like a pyramid, and there is the structures that builds up the pillars of BMW Aerospace. So we have vision, mission, strategic objective, and cultures. Gonna move on with the vision first. So what are the vision of BMW Aerospace? So to be the best in class in providing high value product and setting the benchmark in aerospace manufacturing industry. So do you know that the best in class, because it will be repeated, because UMW Aerospace strive to be the best. Right? Why is it high value product? Because fan cascade is produced by titanium, which is a high value manufacturing. So the product itself is costly and it is very pricey. Therefore, is why it is high value. All right, what are the mission of BMW Aerospace? So to be the best in class, again, best in class, fan case supplier to RR. So RR is Rolls-Royce globally, operating a lean and efficient right first time factory, maximizing net inventory turns and to seek continuous improvement. Right. For the strategic objective, I will only go through it because it is not required. Right. It is just an additional information. So the first objective is to produce 250 fan case annually on the dot or on the demand as required by Rolls-Royce. Second one, 0 defects. So we want to produce 0 defects part. Third one, to be the employer of choice. And finally, to uphold the highest safety standards. All right, these are the cultures of BMW Aerospace, where you normally will refer it to HV up, HV UP, honorable, vibrant, unshakable, and pioneering. So there are other cultures that are in the segment of each HV up, right? Including open and transparent, ethical, speak up, engage, autonomous, self-propelled, control change, and innovative. Right. So these cultures will make up BMW Aerospace. So we're gonna go in. All right. So this is the organization chart of BMW. So there are approximately around 150 employees in the organization, and there are 7 departments, right? If we're looking at the pictures, the person in the topest pictures is the head of the plant, right? He's Mr. Rahul, and under him there is 7 departments, 7 heads of departments. So there is finance, human resource, supply chain, engineering, quality, business development, and finally the production department. So under the 7 managers, there are the support team, which consists of HR and ICT and the finance group. And we refer the team of 3 to the production department, quality department, and the engineering department. So this team of 3 will propel the operation in UMW Aerospace. So what is the product of UMW Aero, right? We're going to be looking on the analysis for the developed product as well later on in the slides. All right, so I'm going to show, okay, so there is currently 2 products that is produced by the plant. The first one is, you can see the top left is the Trent 1000 aero engine. So what UMW Aerospace produced is just only the fan case kit, right? So Trent 1000 is used in Boeing 787 Dreamliner, while the Trent 7000 is used in the Airbus A330neo. So both of them is the fan case kit, right? All right, it comes to the next part. So what is DFX? So why is DFX important? So DFX, or Design for X, is an additional component that is included in the design process to fulfill the requirement that is expected by the consumers or our customers. So why is it important? Because DFX is a process of optimizing for a certain purpose. So we will see Design for X. So Design for X can be split into 3. We have design for cost, design for manufacturing, and design for environment. And as for UMW Aero, the developed product is develop a design for manufacturing. So let's see, what is design for manufacturing? So the process of optimizing the manufacturing of a part, product, or design of a component with the objective of making a product that is cheaper and more easily manufactured. So there's 3 things that is highlighted: optimizing the manufacturing to cheaper and more easily manufactured product. So DFM will allow manufacturers and organizations to identify and prevent mistakes of discrepancy that might arise during the production or the implementation stage. This understanding of the usage of DFM can help the company to manufacture the fan case kit. Okay, so this is the exploded view of the final fan case assembly. So this is what UMW is producing, the outer case, as you can see. Right, there is 4 subcomponents that makes up the fan case kit: the front face fan case assembly, the mount ring assembly, rear case assembly, and the outer guide vane assembly. So today we will be looking only on the outer guide vane assembly. All right, so we will be using DFX to analyze the outer guide vane assembly. So in aerospace industry, we will use a report called FAIR report, or First Article Inspection report. So it is a comprehensive review of the engineering documentation and the manufacturing process from the raw product until the final product and until gave it up to the customers. So it is a comprehensive review, as I said. So it is aligned to the principle of DFM, but we will see later on what is the DFM principles. So the principle examined during a DFM process include these 5: process, design, materials, environment, and the compliance or testing as per requirement. We will be looking on one by one on the principles. So we'll start with the process. So process is the manufacturing process to produce a part or component. So these are the process. There is welding, dressing, vane filling, machining, and assembling. And finally, this end. So each process will be followed by a quality inspection stages to confirm the part is producing according to the specs. The next one, design. So design of the product to be manufactured. So this design and drawing is based on RR drawing and their specs. So what UMW Aero can give is providing feedback currently on what to be improved in the design. Okay, the material, the type and properties of the aerospace material. So I'm gonna go highlighted 3 types of material: the titanium to produce the inner ring and the OGV, outer guide vanes, the aero die that will be used to inject the vanes to make it more sturdier but maintaining lightweight, and finally the puddle panel. So it is blocked by the employees, but it is a type of composite that will be attached to the inner wall of the inner ring to provide drainage for water, right? An environment is the design must able to withstand an environment that it will be subjected to. So there is currently 2 or 3 environment that is controlled. So the first one is the usage of shielding gas in welding processes. So you need shielding gas to produce a nice weldment, and the humidity and lighting in the facility are controlled under specific requirements to keep each process in check. So the minimum light intensity in the facility is 500 lux, so that the employees can see what are they doing, right? So 500 is the minimal. And finally, it comes to the compliance and testing. So it is a verification method and process performed to the parts to ensure that it is authentic. So there are 3 methods, right? 3 main methods. So the first one is a tap test hammer, which is to check the vanes of the OGV, right? To make sure that it is filled. And the next one, it is using coordinate measuring machine to check this drawing, the length, the dimensions of the OGV, and finally magnifying glass, which is used to inspect visual defects or any visual dents, right? To make sure that it is compliant to complete its process. When it comes to the recommendation, so I have 3 recommendations to give to the product. So the first one is education, training, and focus group. So we need to exchange of ideas and information, because in the welding process, there is still a lot of variables that you can play around. So sometimes we can produce good results, sometimes it's bad results. So it's best that we can exchange between welders and engineers, so you can come up with a consensus to produce a solution. The second one is drawing reviews and bonus tolerance. So review any design incompatibly with the process with the customers. So in this case, RR, and request additional drawing tolerance, because sometimes the dimension is a bit sensitive. So you can get a non-conformance, a NG part. So it is best if you can come out with a common ground with the customers. So the third one is the mechanical joint. So we will install the puddle panel using screws and fillers, ditching the adhesive bonding process, so that we can achieve more while but sacrificing less, right? So we see, so if we use the first recommendation, we will have information coming through, and there will be more testing because you have more information, and finally we can obtain the welder's feedback on the process, right? So if the third recommendation is produced, so we will have 67% waiting time reduction from 30 hours down to only 10 hours by using screws and fillers. So it is very huge numbers. All right, let's recap. So there is 3 types of defects, DFX, DFC, cost, manufacturing, and environment. So the parts that is produced by OGV, that by UMW Aero, is the OGV, which use DFM to manufacture. And there is 5 principles of DFM: process, design, material, environment, and compliance or testing. And finally, the recommendation that is given is to promote communication, to seek opportunity and to change any and what the any things that you can be changed, right, to better solution, to a better process. All right, I'll finish the presentation with a quote from Paul Rand. So design is the silent ambassadors of your brand. So think wisely when you design, and hopefully the company, the organization can prosper more and be successful. Right, thank you.